going on page 154 when we're done. So we talked about arithmetic series yesterday and basically what series were. So today we're going to look at the geometric series. The definition is just the sum of a geometric sequence. So the sequence is the list, the series is the sum. So if you want to find the sum of a geometric series, this is the formula you use. S sub n is equal to, and it's right over there as well, a1 times 1 minus r to the nth power all over 1 minus r. And that nth power is on the r. It's not on the outside of the parentheses, it's on the inside. So you're only taking r to the nth power. N is the number of terms still. A1 is the first term. And what is R? Ratio. It is the common ratio. And A1 is not necessarily the first term in this sequence, but it's the first term in this series. It's the first term that you are using to find your sum with. So we may not, we may have like a chunk from the middle or something else, but that first term that you're actually finding. And if you look at these two formulas here, like this was the one from yesterday, this is the one from today. Yesterday for arithmetic series, we had to know what n is. We still have to know what n is. We had to know what A1 is. Still have to know what A1 is. But we also had to know what AN is, the last term. We don't care here. Okay, but we do need the ratio here where we didn't need the difference there. So it needs a little bit of different things. Make sure you're paying attention to that. All right, so we're going to start with number 1. It says find the indicated sum for each geometric series. So we could figure out what's happening and then actually find the first 9 terms and add them up, but we're not going to do it that way. So I need a few things. The first thing I need is n. What is n? 9. It's right there, right? N is 9. So I'm going to find the sum of the first 9 terms. I need A1. Well, that's 2. And then I don't care about A9, but what else do I need? R. And what is R? 5. Because I can just take 10 divided by 2. I get R is 5. That's all I need. Now I can substitute it in. So the sum of those 9 terms is equal to A1, which is 2, times 1 minus 5 to the 9th power, all over 1 minus 5. I highly, highly encourage you to actually use that fraction button on your calculator. Because some people are not, and they're using parentheses, which doesn't make things wrong, but you're less likely to get something wrong if you can actually see it like it's on your paper. So use it, especially when you're going to get a fraction and a fraction. Makes it really nice. Okay? So you get S9 is equal to 976,562. Do we agree with that? Okay, good. All right, so let's look at number 2. What is n? 8, right? A1 is 72. R. What is R? Negative 1/2. Good, because we're dividing by 2. That means we're multiplying by 1/2, and the signs are changing, so it's negative, or they're alternating. So we got all our pieces. It's not any more difficult than this one, but the reason I wanted to do this one is because it's going to have a fraction and a fraction, and I want you typing it in your calculator like that. So the sum of those 8 terms is equal to A1, which is 72, times 1 minus a negative 1/2 to the 8th power, all over 1 minus a negative 1/2. Oops. So right here, can I make this 1 plus 1/2 to the 8th power? No, because there's a exponent there. So type that in your calculator, but I want you to use the fraction and the fraction. If you haven't ever done that before, I want to make sure you're actually practicing that. It's way easier than a bazillion parentheses. I mean, you still have to use parentheses, don't get me wrong, but You should get 765 over 16. So if you don't, then arrow to the left so it goes back and you can maybe figure out what you typed in incorrectly. And if you can't figure that out, let me look at it. It's probably a parenthesis issue with your negative if I had to guess. Now on the bottom, could you go ahead and make that 1 plus 1/2? Yeah, absolutely. But, you know, at the top you can't. So make sure you know the difference. Or if you're not sure about the difference, just put it in exactly like it looks and don't try and change anything. Okay? Do we have any questions at this point? We're all good. Okay? I'm more worried about calculator skills on this one than I am you actually figuring out this series. All right, let's jump down to number 5. What is this Greek letter called? Sigma. Okay, so this is your sigma notation. That means I want the sum of terms 1 through 7, right? So what is n here? 7. Right, it's pretty easy. And I'm also going to need a 1. I could substitute 1 in. If I did that, 1 minus 1 is 0. What's negative 4 to the 0 power? 1. And so I get 3. Is that a big shock? Shouldn't be, because if you look at the geometric sequence formula, that is a sub n equals a1 times r to the n minus 1 power. Isn't that exactly how that's set up? Which means this is a1. And what is negative 4? R. Make sense? I mean, it's right there. Arithmetic, you can't always just pick them out like that because if you could simplify those down. You can't really simplify this down. So we have all that. A1 is 3. It's right there too. So then we just substitute it in. The sum of those first 7 terms is A1, which is 3 times 1 minus a negative 4 to the 7th power, all over 1 minus a negative 4. All right, what questions do you have? All right. Next example is pretty much exactly like that with some different numbers. So flip this over on the back, and let's look at number 10. So number 10, we've got some sigma notation, but I only want the sum of the terms 5 through 12, right? So I'm still going to need to know what n is. What would n be here? 8, because I have to do 12 minus 5 plus 1, right? So n is 8. This is A1. This is R. However, I do need something else here, because in the formula where it has A1, that represents the first term in your series. The first term in our series is not A1. The first term in our series is A5. So I need to know what A5 is. That's easy to find. I substitute in. I get 1 over 20 times a negative 5 times 5 minus 1. So figure out what A5 is. Should be 125 over 4. Okay, so the things I need to substitute in, I need n, I've got that. I need r, I've got that. And I need the first term in the series, which is A5. Okay? So the sum of those 8 terms is equal to the first term that I want to sum up, which is 125 over 4, times 1 minus r, which is a negative 5, to the 8th power, all over 1 minus a negative 5. Does everybody understand why I'm not using 1 over 20? Okay. Figure that out. Try your fraction and a fraction again. Watch your parentheses. The 120? Okay, so in this formula that we're not doing number 9, so I'll write it right here. Sn equals A1 times 1 minus r to the nth power all over 1 minus r. This A1 right here, it doesn't necessarily literally mean A1, right? It means the first term in the series and the numbers that you are adding up. And so since we are starting with the fifth term, the first term that I'm using to add terms up is A5. This is the first term in that addition. Like if I was literally going to find them all and list them all out, you know, so I list them all out and here are all my terms, right? So I have them all listed out. I'm not starting here, which is literally A1. I'm starting with 2, 3, 4, 5. I'm starting at A5, right? So this is the first term in the series that I'm using. That's what goes there. Does that help? Otherwise, if I put 1 over 20 there, I'd be finding the sum of terms 1 through 8, and I want 5 through 12. Okay, does that help? Good. Anything else? All right, let's jump to number 12. It says, Amari invested $12,000 in a retirement plan with an expected annual return of 7%. What is the balance in the account at the beginning of the 30th year? All right, so let's talk about this whole beginning of the 30th year. All right. On the day you are born, are you 1? You're 0. You're not 1 until a whole year later, right? However, when you put money in the bank on day 1, that money is starting its journey, right? So at the beginning of the first year, he has $12,000, right? And so at the end of the first year would really be the beginning of the second year, right? So if I said how much money does he have at the end of the first year, the years are actually 2 because I'm using them at the beginning. Does that make sense to you? So if I'm starting with the beginning of the first year and going to the beginning of the 30th year, that's 30. If that said the end of the 30th year, how many years would it actually be? 31. Does that make sense? That's where your wording is important there. So since it's the beginning of the 30th year and this is the beginning of the first year, then N is 30. Right? That's why there's that clarifier of beginning, not in the 30th year or something like that. Okay? So N is 30. My first term is that $12,000 that he started with. And then I need R. What's R? .07? Okay, let me ask you this. All right, so he starts with $12,000. Find, use your calculator, what is 7% of $12,000? $840, right? So at the beginning of the first year, he's got $12,000. The beginning of the second year, he's got $12,840, right? So now take 12,840 and divide it by 12,000. And you get 1.07, which is what some of y'all were saying. See, the difference here is this. The 7% is just how much he's getting extra that next year. The 1.07 is technically what this is being multiplied by to get you this. Does that make sense to you? That's what the percent button on a calculator does when you do like plus 7%. It's actually doing that for you. Not all calculators have a percent button, right? So if you're trying to calculate the percent, yeah, you could find 7% and then add it. But if you're trying to find your total with tax to make sure that you have enough pennies in your pocket because you dug them all out of the couch and you're a little desperate at this point, because if you haven't ever been there, you'll be there one day. So you're counting your change, then you can take your total and multiply it by 1.0825. Bam, there's your total with tax. Right? So make sure you know how to do those things just like in life. Yes, you could find it and then add it, but this is what it's asking for here. Does that make sense to you? We're good? All right, so now that we have that, I have everything I need. I want the sum for those 30 years. That's equal to A1, which is 12,000, times 1 minus 1.07 to the 30th power, all over 1 minus 1.07. Here's another reason it's important for you to have some concept of this. I'm not saying that you're going to go using that exact same formula sometime in your life to calculate your bank balance or whatever. It's not what I'm saying. But what I'm saying is $12,000 at the beginning of his career. Like, that's a lot of money. Most of you probably don't have it sitting in your bank account right now to go invest somewhere. But put that $12,000 in. He didn't touch it. He didn't add any every year. That's not what this says, right? All that got added was that interest, and he didn't touch it for 30 years, and that $12,000 turned into $1 million. Now, 7% is a pretty hefty interest rate. Like your regular old savings account at your bank is not going to give you that. But if you invested your money in stocks or bonds or something safe, I don't mean play the stock market. That's kind of like gambling depending on what you're doing. But you can find things that are more than what your general savings account will do. Property. And sometimes that's a gamble too, but yes. So something that you could invest it in, then you could have money at the end of your life. It's important for you to understand this while you're young. I'm telling you, I've been there, and I wish somebody had said these things to me. Even if it's just a teeny tiny bit, put a little bit away and don't touch it. Just as much as you can, even if it just starts being $5 a month. I mean, right now, if you don't even have a job, you don't even have anything to put away. When you get your first job, you're not going to have thousands of dollars to put away unless you get it after you graduate. But, if you're going to work before you graduate from college, you're not going to have thousands of extra dollars to do that. I understand that. At least open a savings account. Start putting a little bit away and don't touch it. See if they've got some sort of special account where if you literally can't touch it. There's some of those where it won't even let you take it out, and then whatever. But think about those things while you're young. You'll be appreciative later on, trust me. All right, I'll get off my soapbox. Go to the next piece of paper. Stop my lecture with that. 155. All right, so I shifted this stuff, and I did not catch this until after it was copied, so we got to fix my mistakes real quick. This S1 through S6, they sort of shifted up and it looks weird, so just kind of mark those out and then fill in S1, S2, S3, S4, S5, S6. And then do the same thing in the second one. The S's need to go away and fill them back in. All right, so what this says is we want to find the partial sums for each of the infinite series below. So in this first one, S1, that means the sum of the first term. It's 1/2. We're going to use decimals here, so this is 0.5. Then I'm going to add the first two terms. So 0.5 plus 0.25 is 0.75. Right? Now, use your calculator. Start with 0.75. Add 1/8. Put the number here. Then add 1/16. Put the number here. Write down all the decimals you see, because it won't be a bazillion. Just write down everything that you see in your calculator and fill in the rest of that chart. So it started off changing kind of slowly, right? From kind of quickly, I'm sorry. From 0.5 to 0.75 to 0.875. Then it started like slowing down how much it was changing. And it looks like if I keep going, this number, it looks like it's getting closer and closer to what? 1. And it is. So if I add up 1/2, if I continue this series literally until infinity, then the sum is 1. Now, here's the key word here, though. It says a series that approaches a certain sum. So it technically never actually gets there, but it gets really, 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 really close. Does that make sense? It's kind of like my distance from here to that podium. If I cut the distance in half and then I cut it in half again, and I keep just cutting the distance in half, will I ever actually reach it here? No. But it's like my limit, right? Like it's like kind of like an asymptote. It's like a limit, and we'll get to those limits. But if this happens, if it approaches a certain sum, it's not always 1, just some certain sum, it's called a convergent series. Over here, when we do this one, we're going to get 0.5, and then 1.5, and then 3.5, and then 7.5, 15.5, and 31.5. So this is approaching what? Infinity. And infinity is not a number, so it doesn't have a sum. So it says a series that does not have a certain sum is called a divergent series. And figuring out if it's convergent or divergent, super easy. Let's look at what that means here then. So it has everything to do with the absolute value of R. Okay? So it doesn't matter if it's positive or negative. We're just looking at the absolute value of it. If it is, it could either be less than 1 or greater than 1. If it is less than 1, it is convergent, and we can find a sum. If it is greater than 1, then it is divergent, and we can't. Okay? So it's pretty easy to tell if you can find R, you're good. If it's convergent and you can find a sum, then the sum is equal to A1 times 1 over 1 minus R. That's for a convergent infinite geometric series. So it says determine if the series is convergent or divergent. If it's convergent, then find the sum. All right, so I need to figure out convergent or divergent first, which means I first need to figure out what R is. So on number 13, what is R? -6. So would it be convergent or divergent? Divergent. So this is divergent, and I have no sum. All right, number 14. What is R? 1/3. So is it convergent or divergent? Convergent, which means I can find the sum, so I'm going to use that formula. The sum is equal to A1, which is 72, times 1 over 1 minus 1/3. So remember, it doesn't always converge to 1. It can converge to, any number that would make sense. But we good? All right, jump down to 17. So 17 has got this sigma notation going on. Notice I'm going from 1 to infinity this time, so it's an infinite sum that I want. This right here, what does 224 represent? A1. What does 3/4 represent? R. So is this convergent or divergent? It's convergent because it's less than 1, right? Or the absolute value is less than 1. So it's convergent, which means I can find the sum. All that stuff was given to me just in a different form. So the sum is equal to A1, which is 224, times 1 over 1 minus 3/4. You get 896. Good. All right, what questions do you have? All right, then y'all do number 18 while I pass out the assignment. Ignore this random 8 that's popped up inside of it because the whole thing's just a mess. Yes. Yes. And because it gave you a decimal as R, then your answer should be a decimal. Like it should kind of match the pattern of what's happening there. Okay. All right. Any questions? All righty. Go ahead and get it glued or taped in. Don't forget your pink card.